Hello, everybody. Welcome, welcome. Don't you worry. The bar will be open. I will not interrupt your trying to get a drink. Welcome, everybody, to our today's Science Slam. Welcome to the second day of the Berlin Science Week. Hey everybody, I'm Jochen. I have the pleasure of being your host tonight, and I welcome you in the name of 6 wonderful clusters of excellence, namely unifying systems and catalysis, Math Plus, contestations of the liberal script, matters of activity, science of intelligence, and neurocure. Yeah. Now everybody is clapping, but I guess nobody is knowing what I'm talking about. So, what does it all mean? Well, if you look at the news today, you could really think that humanity has gone mad, right? Climate change, crisis here, turmoil, I don't know. Have we forgotten history? Do we really need to burn all the fossils? What is intelligence anyway? Natural intelligence, artificial intelligence? Is mathematics good for anything? We need new energy sources. We need new materials. And so on and so on. And the good thing is that there are actually brilliant young people who work on all the problems that I have just mentioned. And we have a couple of them here. And the people and the universities they work on, the institutes they work on, they're shared forces. And said, let's get together and get funding together because we work on similar problems. And these are the clusters of excellence that I just named. Unifying systems and catalysis is concentrating on catalysis, right? Biology, physics, chemistry, and some other people are working there. Math Plus, obviously, they would do some math, I would say, right? Contestations of a liberal... let's just say scripts. They just do some historical stuff, I would say. We hear more about this in a few minutes. Matters of activity. Some matters, different matters. Well, whatever that means. We will hear more about that also. Science of intelligence. What is intelligence anyway? People can't have that, I'm sure of it. But we will hear of what intelligence is. Unfortunately, only of one slammer tonight. The other got sick. He gave me a call. I could hardly understand him. He was like, I'm not feeling so well. So unfortunately, Benjamin will not be with us tonight. But Emma is here also from the same cluster. And if the brain gets hurt, then we sometimes need a cure, and that's what neurocure is focusing on. So really brilliant people, very important topics, and again, they join forces to get funding to deal with these problems. That's the clusters of excellence. But don't worry, we're not here to hear super boring, technical, long lectures. No, we're here at a Science Slam. So that means that these projects, these research projects will be presented in a way that will entertain you and that will stick in your head. Who has ever been to a Science Slam? Who knows what a Science Slam is all about? Please show up. Ah, okay. So that means that a few of you have never been to a Science Slam. So let me enlighten you what a Science Slam is all about. The Science Slam is defined by basically 4 rules. The first is people on stage are only allowed to speak about their own research project. They're not about to talk about something else, right? Second of all, it has to be understandable. It has to be entertaining because you vote the winner of the day. And we have to set a time limit, which is 8 minutes today. And this is very important because if you don't set a time limit, scientists will never stop talking, right? And this is where you come in place. I have this very important Zeitschwein here. Right? And I guess you are able to count to 8, right? This is secure. You never make mistakes when count to 8. Great. And you have a time-taking device with you, maybe a smartphone or something like this. Great. So please, great applause for our volunteer. Your name is?
Achim.
Please, great applause for Achim. Achim is responsible for controlling the Zeitschwein. So after 7 minutes, he'll do something like this. Yeah? And then the people here on stage will know, oh goodness, time's flying, and they have only 1 minute left. They will not react to it. Achim, don't get nervous, right? When you don't see a response. After 8 minutes, you can have fun, right? Then you can do something like this. And that's the signal for me. So here, try, give it a try. Yeah, be nice. And now after 8 minutes, yeah, exactly. So that's the signal for me. After 8 minutes, when the people still keep on talking after 8 minutes, we're all fed up, we don't want to hear more, we can't cope with all this information, then I will come on stage. Slowly, I'm a polite person. Yeah? Then I come closer, and closer, and closer. And if they still don't stop talking, then I might rub myself on them, and that will be really so uncomfortable that I will force them to stop. And that's, that's why we have the Zeitschwein. Great applause for Achim. Thank you. Okay, but then I said that you will vote the winner of today, and that you will also do by clapping. And here we'll have to make a little test, right? We're in Germany, we'll wake up your emotions now. Now let's do a test now. And the people in the front, where you sit in the front to the left here. When I count to 3, we say that it was just good, not more. So I want to hear you say good, right? 1, 2, 3. Okay, that's enough. We will not hear that, but that was? Thank you. A bit better. That's the people from here to the right, the people sitting. I would say, yeah, the talk was a bit better. It was fascinating, let's say. Right? 1, 2, 3. Okay, let's try this again. 1, 2, 3. Right. But we still have room for more, right? The people in the back and the people on the balcony after 3, that was really enlightening, that you call eureka. So please, 1, 2, 3. Eureka. Right, and we can have here a little, wie heißt das? Anyway, good. Let's try this. Exactly, you got the drill. Okay, but this will not be enough afterwards. You can do this during the show or directly after the show to give the people a direct impression of how you felt with it. However, at the very end of the show, when everybody gets on stage, we want to see who's the winner of today, right? And this you will do by clapping. And we have a very complicated system, but you will understand it. It counts from 1 to 10. Achim, is 10 still okay for you? Yeah? Okay, Achim is okay. Okay, so an applause of the stage 1 we will not hear today, but that would be like everybody fell asleep and then you wake up because the people is leaving the stage, right? So how would applause of stage 1 sound here tonight? Yeah, please stop. That's so sad. We will not hear this today, okay? An intermediate good slam would be like stage 5, I'd say. That would really be the bottom of what we will hear today. You understood a bit, there was a bit of content, there was a bit of context also. Maybe you remember that there was a slam, not really much of it, but heck, the person dared to go with this on stage. So how would this intermediate stage 5 applause sound like tonight? Oh, okay. Oh, you're from Potsdam, right? Oh, yeah. Okay. Okay, so that would be the intermediate. Like stage 10 is maximum, okay? Stage 10 is enlightenment. Something explodes in your head, maybe even in your pants. You will never forget that. You will directly after this slam go to the university, enroll in what he or she studied, and will do this for the rest of the night because you heard the best talk of your life. How does a stage 10 applause sound like tonight? Yeah! Exactly. Now keep on doing this. When you see the slammers of tonight, Johannes Hess and Tobias Klee from the Freie University for the Excellence Cluster Scripts. Maryam Karimian from the Humboldt University for Science of Intelligence. Guillermo Olicon Mendez from the Free University for Math Plus. Ram Prasad Misra from the Humboldt University for Uni Suiscat. Emma Sicher from the Humboldt University for Matters of Activity. Gilberto Solausa Buenrestro from the Charity for NeuroCure. Oh, he brought some fans, okay. And Tanya Fernandez del Valle Algili something from the Charité for NeuroCure. Sorry, that last name was too complicated for me. Okay, now we have to find out the order, right? So that's why I have this complicated lottery. You just pick some notes, unfold them, read the number, and hold it up. And then, oops,
Eat.
that's this one. Yeah, wonderful. That's where we go. One for you too, because you perform together. Now, please, Tanya, you're number one. Awesome.
Ich glaube, das sind die letzten vor der Pause.
And Gilberto, number 3. And Emma, number 5. Ramprasad is the number 7. Memo is the number 2. Maryam, number 6. And Johannes and Tobias, the number 4. So, this is the order. After the 4th slam, we will have a break so that you can go to the bar, get hammered, and forget everything you've learned before. No, of course not. But now let's start with the first one. So everybody can go off the stage, sit down in the order of appearance. Tanya, you will stay right with me, and I'll say, well, wait a second. That's somebody here. Tanya, now you have to stand right next to me while I introduce you to the crowd. That's okay for you, I hope. Tanya, she's from Mexico. She studied biology here at the Humboldt University. She's interested in the mechanisms involved in memory and decision making. She's currently doing she's a PhD student in the David Owald Laboratory for Behavioral and Physiological Neurogenetics at the Institute of Physiology at the Charité. I had to train hard to say that without accident. She's studying how olfactory memories get consolidated in a fruit fly's brain. And her motivation to do this is this wonderful sentence: I am a carbon bipedal life form interested in life itself and its many forms. The title of her talk will be Memories of a Fruit Fly. And my microphone is here. Here is time is running. Tanya!
Hi, can you hear me? Yes, hopefully, yeah. Okay, hi, I'm Tanya. I am since a very young age interested in the different life forms, as you can see here from my piña tarantula when I was 6. When I was around that age, I was also just looking around for insects and arachnids that would volunteer to be observed, not only their behavior, but also their morphology. The problem too is like when you want to look at all the details they have, is that they're always moving around and trying to escape. So I would put them in the freezer, so they would stop moving, and I could actually look at them. And funny how life works nowadays. I actually observe behavior and sometimes get to observe also fruit flies that went into the freezer. So I can say I'm living my childhood dream. This is one of the many memories that shape my identity. I am what I can remember of me. Remember who you are, Simba. So it's needless to explain why memory is so important, right? But it becomes more obvious when ourselves or someone close to us starts having memory impairments or memory-related disorders. The problem can arise in one of the many, like on the different stages of memory. So first would be like the memory consolidation. So how does an abstract piece of information or an event leaves a trace, a physical trace in the brain, just like this trace is here. The second part would be the ability of keeping those memories, so the storage of that memory, keeping that from fading away. And the last part is the appropriate retrieval, so being able to access that information appropriately. And I am especially interested in the first part, as already Jochen said, the part of how does those traces happen in the first place. And in order to understand that, I am training flies. So I will go to the methodology later. First, I want to talk about why fruit flies. So these little creatures have been very used in research since the beginning of the 1900s in different fields. So especially in genetics, development, but also like in immunology. And research in fruit flies has been pretty fruitful. It has delivered around, well, until now, 6 Nobel Prizes in different aspects. And why is that? That's what I want to explain. So their genetics are very well known, as I already said. And a lot of different genetic tools have been developed that facilitate the targeting specific structures and then identifying what the role of these structures might be. So they are capable of complex behaviors, although they have a tiny brain of around 135,000 neurons. Just as a reference, humans have around 8.5 billion. So this reduced number really gives us a fighting chance into trying to understand what is happening between networks. So important to talk about the genetic part. Around 60% of the fly genes can also be found in humans. Here is an idea of how it would look like if we would share more of those genes by Cronenberg movie, the movie The Fly. It's referred to a fruit fly, but to a house fly, not to a fruit fly, but you get the point. Not only this 60% is important to take into consideration, but 75% of known human disease genes have a recognizable match in fruit flies. This is a really amazing opportunity to research or to understand the mechanisms of these conditions. So then we have memory, we have flies. How do you study memory in a fruit fly? And for that, I'm going to introduce you to Flyan, which is one of our many participants in this behavioral assays or experiments, and I'm going to walk you through a very simple concept of conditioning or association. So first, we have Flyan smell an odor that he has never experienced before, and this seems rather irrelevant. Nothing else happens. Then Flyan is presented with a second odor, this time with accompanied by a sugar reward. So this just got interesting. Then we ask Flyan to go for a walk, depending on what we want to investigate. So like 2 hours, 3 hours, depending on the type of memory, right? So midterm memory would be around 3 hours. Of course, we have to do the adjustments in fly time. And after waiting, we give the option to Flyan of the two others, and what do you prefer? We ask him what. Flyan chooses correctly, and he most probably preferred the other that was previously presented with the sugar. But what happens if we train Flyan and we show these others to him, and then start messing around with its brain? And do you remember about this genetic tools I talked to you about? Well, this is when they become very handy. This allows us to dissect the function of different circuits. And with the use of optogenetics, so with light, you'll hear more about that. And with thermogenetics, we can modulate the activity of certain neurons at very precise times. So this allows us to find out the individual and collective role of different neurons in a circuit, and for a determined process, so in this case, memory. So you choose like the neurons that you're interested in, and then you can turn them on and off and check out what happens afterwards. So we go back to Flyan after all these fancy interventions, and we ask him again which odor does he prefer. And if the writing of the memory was indeed affected by our interferences, then the process of the memory process will be interfered, and he won't be able to remember and won't show a preference anymore for any of the odors. So furthermore, we can also use other tools such as drugs to see the effects on memory. So let's imagine that we have a drug that affects this triangles or receptors in different parts of the brain. And with the combination with the genetic tools, we can also see if the function of these receptors is different in different neurons, right? So like in different groups, because the drug will affect everywhere, but we can also target specific parts, and we'll get more information of how that works. And when we found important neurons or relevant neurons for this process, we can then take a deeper look, and not only using the drugs, but because then we know that neurotransmitters are, or like how the communication between these networks is modulated. But we can also see the activity under the microscope with really nice, cool microscopes. And we can take a look on how the activity changes in these neurons. So why do we want to know all about this, about Flyon's brain? Well, because we want to disentangle, the molecular underpinnings, right? And the more information we have on how these processes might work, the more specific we can develop treatments to treat these different memory conditions. So at the end, we can always say that humans are just slightly more complicated fruit flies, because just as Flyon, aren't we all just trying to make some sweet memories? Thank you so much.
Thank you, Tanya. Escape. Okay. Now prepare for the next speaker of tonight. Guillermo Olicon Mendez, or how I am allowed to call him. Not now! I first introduce him. He's also from Mexico. He looks beautiful, even under the mask. He made a bachelor and a master. He got a bachelor and a master in mathematics from the University of Mexico, and he did his PhD in Imperial College in London. He came to Berlin as a postdoc at the Freie University in the group of random and multi-scale dynamical systems, where he's focusing on work in the intersection between dynamics, probability, and mathematical modeling. He does so because he wants to use mathematical methods to better understand the behavior of chemical reaction networks. The title of his talk is A Modern Story of Achilles and the Tortoise. You ready? You tell me when this starts? Yeah? Okay. Clear the stage. Time is clicking. Time is clicking. Clock is kicking for you. Big applause for Guillermo.
Thank you. Thank you. All right. Well, as Jochen already said, I'm Guillermo. You can call me Memo if you're my friend. Or tonight you can call me Bad Bunny. Ya tú sabes, huh? Thank you very much for being here. So tonight, I'm going to tell you a really bad story. It's a story about Achilles and the tortoise. But look, I decided to change the main character because I can't relate to a young, beautiful, white, cis, male Greek hero because I can't relate to that. So our story is going to be called now A Modern Story of Achilles the Rabbit and the Tortoise. Hope you like it. So, once upon a time, Achilles the rabbit and their friend, well, the tortoise, were out on the fields doing whatever. And then at some point, Achilles the rabbit says, "Hey, tortoise, what if we do something? What if you just start running, and if I catch you, well, I'll do all those things that you actually like." And the tortoise was like, yes, rabbit, yes, I would love to do that. Yeah, so should I start now? Yes, just run. And if I catch you, I'll do all those things that you actually do. And then, at some point, the turtle starts running. And when Achilles the rabbit realizes that they're about to catch the tortoise, they see that the tortoise has moved already. So they say, okay, I'm going to run faster, and they do so, and then they realize that once it's about to catch the tortoise, it moves again, and it never catches the tortoise. And this happens over and over for the rest of eternity. So they are condemned to be trying to catch each other without ever being able to, well, do all those things that The truth is, if you're a mathematician, you know that this is actually false. The story is actually different because we know that, that Achilles the rabbit actually catches the tortoise. This is because we have a concept, which is speed. And if you're fast enough, you will be able to catch whatever you need, right? So for example, the kind of fast and slow dynamics that we study in our group are, for example, chemical reactions. And you can see that it's a reaction that is red, and it's very slow, and then quickly goes into a slow color, right? So you can think of this as if we're measuring tortoise and rabbits in chemicals, right? So for example, we have a tortoise face where it's very slow, and it's just red, and then very quickly we become a rabbit, and then we become blue. So we kind of study slow, fast systems this way. And for that, just to make it very, very clear, I want to do a live experiment. So I'm going to need, for my next trick, I'm just going to pull a couple of rabbits out of my hat. So you, please, can you come here to the front? And can you please come to the front as well? An applause, please, for these people. I'm going to tell you very quickly the rules. It's just going to be a race. One of you is going to be on one side. What? It's just a race. Huh? And the other one is going to be on the other side, okay? So the thing is, I'm going to have my hands up, and as soon as I put them down, you have to run to the other side. Actually, no, you're going to be rabbits, right? So you're going to start hopping to the other side of the stage, okay? And the first one to reach the other side of the stage wins. So please grab your positions. And actually, now that you're moving there, what I didn't tell you is that you're going to be blindfolded. Right? And yeah, so you actually don't know when I'm putting my hands down. Okay, and just to make it very, very interesting, let's make some noise. Make some noise. Wow. Just go wild. Just scream, shout, whatever you want. This is your only chance tonight. Actually, not, but okay. You're going to be distracted by noise as well. So that's going to make it more interesting, isn't it? Okay. So please make some noise. Helchen, come on. Rabbits, when you think I've put my hands down, just take the cloth off and hop to the other side whenever you think it's ready. Is it time already? Have I given the signal? When is it time, huh? Is it now? What does Helgen say? What does Helgen say? Yes! Thank you, thank you. A drink for her, please. My tab is under the name Johann Müller. What did we just see here, huh? So this is the kind of things we study in mathematics. So this is a slow, fast system. A slow and a fast system under the influence of noise, okay? Literally, we don't do anything else, at least in our group. This is the thing. We have the perfect ingredients for creating chaos. So we need a slow dynamics, a fast dynamics, and something that is perturbing. And these three ingredients create instability. So it was completely impossible to predict, well, a little bit predictable actually, but it was completely impossible to predict who was going to win, who was going to take the mask off and then start running, or hopping in this case, right? So this kind of analogies, this is what we study in mathematics. So of course, we can think of whatever slow-fast system you want, right? So for example, we can have disease transmissions, right? This happens very quickly between people, and you can have some perturbances with seasonal changes, right? If it's a little bit colder, then diseases spread easily. Or you can have nutrition habits, which is something that you do every day, and then the growth of crops, which is essentially a yearly process, so it's a little bit slower, right? Or you can have communication between individuals, but this happens on a daily basis, while the migration routes happen every year. Or you can have the dynamics in your brain, right? But the sleep patterns happen only every day, once. Well, a little bit more for some people, right? The consumption habits, it's something we do every day, and still the fashion trends, they can take years to develop. Or even something to more, related to our days, war battles are things that happen every single week. And the peace negotiations can take years. So if you think about it, I was talking about bunnies and turtles, but in fact, it was never about the rabbits and the tortoise. The big problems in science and in humanity, it's not about turtles and bunnies. Well, you actually can think of it, but it's about real stuff, and we need mathematics to solve them. And the thing is, we have the tools to start understanding them. So if you really have a problem in your life, and as in like really meaningful for humanity, just call your local mathematician. They'll be happy to help you. Thank you.
Thank you. Now that was number 2. Number 3 also is from Mexico City. Yeah, it's not only that we have 3 Mexicans, no, they're starting the show. Actually, welcome with me, Dr. Gilberto Solazo Banduestro. Yeah? He studied medicine in Mexico City and came to Berlin to do his master and a PhD in medical neurosciences here. Exactly. He is currently working as a research physician in the outpatient clinic for multiple sclerosis in Campus Charité Mitte as part of his first year training in neurology. He's studying the eye as a means to characterize and diagnose demyelinating diseases. He'll tell you in a minute what that means. And he's doing that because he wants to improve the situation for patients with neurological diseases. The title of his talk is The Eye as a Window into the Brain. Please welcome, oh no, it's already here, Gilberto.
Thank you very much. Also, thank you for trying to say my complete name. Hello, everybody. So now you know my name. I don't have to present myself anymore. So I would like to start my presentation talking about Iris Augenbraue. So Iris Augenbraue is a visual artist. She, besides making art, she really likes to go to the fair. But from all the attractions that there are in the fair, she really likes to go to the bumper cars, right? You know, they're really colorful. So this last week, as every last week of October, she was there. She made a line, waited to get into the bumper cars. She was really, really excited. Bumper cars is where she can let herself go. She was sitting there, letting all the adrenaline rush go through her veins. So she was waiting there, waiting for the light to go off, to get green, but then something happened. Suddenly, all the bumper cars beside her started to dash and collide against each other, but something's wrong. Like, the light actually didn't went green. It was getting like pale and dull. Something happened. Was she hallucinating? We don't really know. Suddenly, a sharp pain started to appear behind her eye. She couldn't see, and the colors were dull again. So she was really, really worried. She left the bumper car, got into safety, and head back home. The next day, she said, well, I'm going to visit a general practitioner, a GP. Once she was with a GP, she explained all of her symptoms. The GP listened really, really, really patiently everything that she had to say. And of course, you know what the GP prescribed? A big cup of tea.
Let me pause because this is much fuller than I expected it to be. But. Uh-oh.
Anyway, so the GP apparently was not up to her standards. But of course, Iris wasn't going to stay with a no. She went to visit a new GP, right? She went to the GP, she found a new one. The second GP didn't know what to do. So what he did was she sent her to an ophthalmologist, an eye doctor. The eye doctor this time, The eye doctor, she couldn't find actually an appointment for the eye doctor until 4 months, which is actually pretty nice for Berlin. I mean, for how long have you guys been waiting for an Anmeldung, right? I'm still waiting for mine, and I've been here for 6 years. Anyway, so while she was waiting for her appointment, she headed back to her place. She went to sleep. 1 week went by, and all of her symptoms were gone. She could see again. All the colors were bright. No more pain. No nothing. 3 more weeks went by. She went to the ophthalmologist, and the ophthalmologist said, like, well, Miss Augenbrae, what? If you don't have any more symptoms, there's no reason to do another examination here. I think you can go home. Because, of course, if doctors are not giving tea to treat ailments, they are also gaslighting you, right? Anyway, so Iris was really frustrated, of course, disheartened. Has this happened to any of you guys? Like, doctors not taking into account your symptoms, acting like you guys are just making things, maybe you don't want to go to work. I mean, I don't blame you sometimes. So Iris was like, no, I'm gonna find another ophthalmologist. She went there, she found another ophthalmologist, and she explained to him all of her symptoms. Once again, you know, she couldn't see well, the colors were pale, eye pain, everything. These ophthalmologists remember actually that some neurological diseases start with a presentation in the eye, exactly what she had. So what he did was he sent her to a neurologist that had another machine called an OCT. An OCT is a machine that allows us to measure the thickness of the retina of our eyes. This is how it looks. This is a retina. This machine, it's amazing because it's non-invasive and allows us to see. In the end, the retina is a projection of the brain. It's said that it's even part of the brain outside of the body. So once the neurologist did the OCT, he realized that the retina of Iris was way too thin for a normal person. Could it have been that maybe Iris had an optic neuritis? Could it be? So this neurologist ran some other tests, mainly an MRI and a lumbar puncture. Dun, dun, dun. And once the results were in, we realized that Iris, I'm really sorry to tell you this, you have MS. However, this is good. There's a good news. The stage of your MS, it's really, really early. That means we can start with some high efficacy treatment and some vitamin D, and you'll be good to go. Once 5 years went by, and Iris, after the treatment, had no relapses. All she had to do was wear glasses in the night if she was driving or when she's working on the computer. 5 years went by, and all her art is just like going all around Berlin. And well, guys, MS is a quite complicated disease. It's a chronic inflammatory disease of the brain. There's no cure, but with the right treatment, we can really hinder the relapses and the progression of our patients. So much that there's many famous people in this world who are with MS, who have MS, like, for example, Christina Applegate, Selma Blair, or for all those Germans that are with us, Schlager singer Howard Carpendale. So, thank you very much. That's for me. Way faster than I thought. Oh, God. Thank you.
Should we use the bandanas?
This is yours, this one? No, this. Okay, now. Okay, now we'll have two persons on stage. Slammers number 4 are Johannes Hess and Tobias Klee from the cluster Scripts. They're both from Germany. Tobias studied history in Heidelberg and Barcelona. He also has a master in citizenship and human rights, ethics and politics. His research focuses on the influence of gender on the construction of Catalan national identity. Johannes studied in Constance, Leiden, and Berlin. He holds a master in political science, and he conducts research on gendered national identities in Catalonia. They're both doing their doctoral thesis in the John F. Kennedy Institute of the Freie Universität, where they focus in the project Gender Borders Memory on investigating how gender structures the inclusiveness and exclusiveness of nations. The title of their joint presentation is Catalan Nationalism, Conserving the Past and Queering the Future. Achim, take the time. Now please welcome with a warm applause Tobias and Johannes.
Esteemed gentlemen, it is an honor for me to welcome you all here at the winter term of 1915 at the Barcelona Institute of Medical Sciences. And I have to excuse myself and our organizational staff for this bewildering introduction. I am, of course, Herr Menegelt Puig-Isais, director of this here institution. And it fills me with joy to face such bright and inquisitive minds as yourselves, eager to learn about the wonders of the human body, its strengths, its complexities, and its deficiencies. Catalonia, more than ever, depends on well-qualified medical professionals. Catalonia depends on us. You may recall the words of our most reputable president, Enrique Prat de la Riba, who realized that our beautiful homeland is a moist breast which will fertilize future generations as it has fertilized past ones. Well, it seems that our mother's bosom has dried up after all. Gentlemen, as I relish when Catalonia feels joyful, I suffer her pains. There's a serious defect which threatens our homeland's very existence. The decline in birth rates. Our population will cease to exist within the century to come. And the reasons for that are quite simple. The sexes, men and women, have forfeited their biological task. Catalonia is not reborn organically. And if we do not apply a remedy to this state of affairs, we expose ourselves to transforming into a monstrous, sick society destined to a premature death. I want to impress on you the dire consequences Catalonia faces if she fails to give birth to her children. This is the enemy. Spaniards coming to our country, invading our country with their lascivious women, grasping at the fertile breasts of our homeland. They bring nothing but disorder, lack of discipline, obsession with physical love, criminal violence, alcoholism, and sexual degeneracy. Many a young Catalan has already fallen prey to the lures of this Spanish disease, the Spanish Don Juanism. They do not know how to properly speak our language. They pervert their personality and feminize themselves by acting Castilian. And even worse, they drag down with them Catalan women, mothers, wives, daughters. Instead of supplying their uteruses with cool, replenishing sperm in the heat of intercourse, they engage in promiscuous behavior. And our poor women, they develop nervous agitation, neurasthenia, hysteria, respiratory...
I am grateful to fate for 3 gifts. to have been born a woman from the working class and an oppressed nation, and to the murky blue for being 3 times a rebel. I am Maria, a Catalan lesbian and poet. I am Nuria, demonstrating with the Asamblea Nacional Catalana. I am Tanya, the first Catalan minister for feminism. We are feministas independentistas, the pro-independence feminists of Catalonia. Maria was the first to write about the struggle we face as women who want Catalonia's independence. In nationalist circles, we're laughed at for saying that the new republic should be feminist. But feminists call us divisive for insisting on our oppression as Catalans. We are all those things at the same time. Feminists, nationalists, radicals, revolutionaries. We dream of independence as a way to improve our lives. Spain has controlled our bodies, our right to divorce, our right to abortion for so long. Even today, Catholic morality is a powerful force in Spain. It's not strange that women, feminists, lesbians, trans people should join the independence movement. It's an opportunity to improve our lives. The same way that women fight for their liberation, oppressed nations have to fight for their liberation. Feminism is not about hating men. And the national liberation of an oppressed nation is not the same as the national supremacy of a state. As feminist revolutionaries, we will transform macho society from below. And society needs to change if we're to find justice as women and as Catalans. We reject Spain's neoliberal capitalism. We reject the democratic deficit of Spain. We reject the triumvirate of patriarchy, master, and fatherland that Spain represents to us. These cannot be the things that follow us into the new Catalan Republic. The Catalan Republic will be born steeped in feminism. But we also have to make sure that our feminist colleagues don't forget our national oppression. We want to do our activism speaking our language, Catalan, not Spanish. Our feminist colleagues fail to acknowledge that Spain oppresses us for being Catalan. Giving up our language for our liberation is not true liberation.
But that's what I've been trying to say the whole time. Spain is an authoritarian aggressor bent on destroying Catalan identity. Thank you for joining us on our journey into the past and into the present day. We are, of course, Johannes and Tobias from the Scripts Cluster of Excellence. And in our research project, we ask ourselves, how can somebody like Hermenegildo Puig y Sayas in 1915 and Maria Mercè Marçal in 1977, or modern-day Catalan feminists, support the same nationalist project? Is there just a distance in time that makes this possible, or is there something else to it?
You may have noticed that we talked a lot about men and about women and about how they're supposed to act. And that's the essence of what we found in our research. That Catalans, or nationalists in general, use gender to denote who belongs and who doesn't in a nation. 100 years ago, the Spanish Don Juan was the antithesis of what Catalan men were supposed to be. And today, Catalonia sees Spain as the abusive husband.
Both these movements sought to liberate themselves from an oppressor, Spain, to whom they want to feel superior and which they admonish. And there's the suppressor Spain coming. Silencing Catalonia. So these movements have the same enemy, but their justifications for their national struggle are different. Hermenegildo Puig y Sayas argued that Catalans were the correct type of manliness, where modern-day feminists say they want to liberate themselves from Spanish oppression and from patriarchy.
So both use gender like team colors. In one case, only Catalans know how to act properly, and Spain is the aggressive invading force. If you think that sounds familiar, maybe you've read what the newspapers say about immigrants coming to Germany or Europe at the moment.
Thank you very much for your attention.
We hope you have a good
great
night.
Thanks, Tobias. Thanks, Johannes. Now we have a 15 minutes break. Get to the bar, get hammered. See you in 15 minutes. Yeehaw, everybody. Yoo-hoo, second half. Yay. Welcome again to the second part of our Science Slam of the Clusters of Excellence. I'm still Jochen. You're still the audience. Are you still feeling good? I don't believe you. Sorry. Are you still feeling good? Come on. Seriously? We try this. 1, 2, 3. Are you feeling good? Finally! Okay, keep on clapping and welcome the fifth slammer of today. She's from South Tyrol in Italy. Her name is Emma, and I'm not allowed to say more. With a warm applause, Emma Sicher. Achim, are you ready? Nick, are you ready? By the way, applause for Nick, who's helping me with starting the presentations. Stage is yours. Big applause for Emma.
Hello, party people. So last Friday, I was close by. I was at Katablau. And suddenly, I had to go. Was I too wasted? No, definitely not. I had to go back to my babies. You know, my babies are demanding. They need to be fed properly. If I don't pay attention, they misbehave. And especially mine are covered with what comes out of it. I imagine some here can relate. Parent life, yeah? So, I'm Emma Sicher. Okay, to be fair, most of the time I look rather like this. Whoops. Spoiler. So, I'm a PhD student in design at 5K Offenbach am Main, close to Frankfurt. And I'm also affiliated with the Cluster of Excellence, Methods of Activity here in Berlin. So now, I want to show you my baby, even if I even spoil. They're beautiful, right? But let me show them bigger to you. They're beautiful, aren't they? Okay, now, some of you would wonder, what the hell is going on here? A designer working with microbes? Huh? So I will take the next few minutes to tell you why. So I work with yeasts. Whoop. Hello. Similar to the ones used to make bread and beer, and bacteria. Similar to the ones used to make vinegar. And they live together. When they're immersed in a liquid containing sugars and other nourishments, the yeasts consume the sugars and produce alcohol. And the bacteria consume the alcohol to produce acetic acid and what here looks a bit like hair. These are microfibers of so-called bacterial cellulose. This is what I meant when I mentioned in the beginning that they are covered with what comes out of them. I will call this an intricate matrix of fibrous extracellular fibers. And they make it for a good reason. Inside it, they can spare energy and also protect themselves from predators. It is a survival strategy. And this is how it looks in real life. A thick, wet gelatin called SCOBY, symbiotic culture of bacteria and yeasts. And probably some of you know it because it is used to ferment tea and make an originally Manchurian drink called kombucha. And the very lucky ones who are going to spend their winter in the Philippines will probably taste the dessert nata de coco, which is actually SCOBY made of coconut water. SCOBY contains cellulose, which is normally found in plants. And we know that it's very important for us because we use cellulose to make clothes, paper, we even eat it in vegetables. However, to extract it, we need to first grow a plant, chop the plant, mechanically and chemically process it to make the substances we want. And this creates a lot of environmental damage, and it also requires a lot of time. Instead, we could get it just by feeding microbes. Depending how I feed my babies, the characteristics, the structure, and the properties of the cellulose changes. My babies showed that they really like industrial rests of food processing of, for example, fruits and vegetables, and they make very valuable cellulose with them. For example, if I give them beetroot, the fibers become purple too. Exactly like us, we are what we eat, and we change if we eat more carbs, more proteins, if we eat healthy or junk food. So do they. In my previous research, I found out that this jelly-looking cellulose can become an ingredient like powder or granulate, can be turned into sheets with different shades, can even become solid foam having a puffed aesthetic, and can even become jelly spheres. With this material versatility, it is possible to make many, many things. For example, compostable packaging for snacks such as dry fruits, for candies, single-use food containers, and generic packaging for a lot of products, even electronic ones. So instead of having packaging made of many materials, we could have them made with one single one that could be compostable, meaning that it can end up nourishing the earth instead of polluting it. When my babies are fed with specific fruits and vegetables, the fibers acquire prebiotic properties, which means that we could even make foods with them, such as rolls made with edible SCOBY paper, healthier popsicles, puffed cakes that can be eaten with your favorite spreads, even pasta, and casings for plant-based sausages. The purple color that you see here is actually beetroot juice. So, being rich in fibers and prebiotics, they can have beneficial properties and effects on our gut microbiota. And this is what I did so far. With a lot of interdisciplinary collaboration, I showed how we can use the cellulose for making packaging, how we can eat it, and this reveals how my babies could help us better manage resources from an ecological perspective. However, in my PhD, I'm investigating one further step. Remember what I said before? Depending on how I feed my babies, the outcome changes. So what can we do more? There is a lot of knowledge all around the world about plants and how they can be used to promote health and well-being in humans, as well as to treat diseases, chronic infections, and conditions. This knowledge is currently getting lost, especially in urban contexts. Therefore, I want to study different plant extracts known for having such beneficial properties and see how my babies like them and how the cellulose they make changes. This has a big potential because plant-related knowledge is present in cultures all around the world, and having different combinations of plant-based meta can be a strategy to promote not only ecological but also cultural biodiversity. And to investigate that, I'm working in the Henge Microbiology Lab, where they hold an expertise about how plants can affect the cellulose production in bacteria. So first, I collected different scobies with different groups of babies around Berlin. I made experiments to see with which babies I am working, and I selected the most productive and resilient group. Now, I'm feeding my babies with different liquids, trying to see how the cellulose grows. And the next step is applications. And you can imagine anything from cosmetics, foods, and biomaterials. And this is why, as a designer, I work in a lab to create new cooperations between humans, plants, and microbes, and to bring discoveries from the lab to society and ecosystems. But now I have to apologize, but I have to go back to my babies. Thank you.
Oh, you're fast. Well, say hello to Maryam. Maryam is from Iran. She studied physics in Isfahan, and then she did a PhD in cognitive computational neurosciences in Maastricht. She's interested in human behavior, and her interest led her to the biology department of the Humboldt University, where she's currently in a postdoc position. Her postdoc, her research is centered on the domain of human collective information processing and decision making. And through her work, Maryam is dedicated to understanding the fundamental mechanisms and key factors that drive and affect the spread of behavior within human groups. The title of her talk is, obviously, Your Decision is Not Solely Your Decision, the interplay of personal choices and social influences. Achim, stage is yours. Warm applause for Maryam.
Thank you. Thanks, everyone. Hello, good evening. My name is Maryam. I'm postdoctoral researcher on human collective behavior or collective information processing, whatever. Tonight, I want to show you that your decision is not solely your decision. But before I talk about this statement, I want to invite you to watch a video with me. I see smile and later laughter was spreading among you as well. You may think about a variety of reasons causing the spread of laughter here or in this metro. But the main reason is actually behavioral contagion. As a matter of fact, behavior spreads like infection. And we call the spread of behavior as behavioral contagion. This phenomenon is an interesting topic for many disciplines like social science, political science, marketing, or even your everyday life. Now watch this video. Behavioral contagion also exists in swarms of social animals. Just see how some animals make beautiful waves by just following each other. They follow their nearest neighbors, those they can see, those they can interact with. And they may even don't understand what is going on. This behavior can have survival purposes. For example, in response to the attack of a predator. They just need to stick to the group and follow their neighbors. They don't intend to make these beautiful shapes. Well, now that you know what behavioral contagion is, I want to continue my speech by answering some other questions. Why at all behavior is contagious? Then, how do we study behavioral contagion? What are our current findings? The less attractive part for you, but the most important part for me. And finally, why do we study behavioral contagion? What is important about these studies? Okay, now let's focus on human again. if it was possible, or maybe it is possible, to follow the trajectories of human behavior or decisions, they could have formed beautiful shapes like what you observed in the video of animal swarms. Who knows? Here the question is, why behavior is contagious? Actually, we copy each other's behavior for two reasons. One is called automatic imitation, like yawning or laughing. You observed it a few minutes ago. This happens unintentionally. However, sometimes spread of behavior or copying others' behavior can be intentional, like this. Poor Joey, he just wants to avoid his friend's judgments. He wants to avoid Chandler's sarcastic comments or Ross's long scientific speech that doesn't end. He has to confirm his friends. So this is called confirmation bias. Next, the most interesting part for me. How do we study behavioral contagion? We have two research lines. We actually integrate these two research lines. One is virtual reality experimentation, and the other is computational simulation of VR experiments using mathematical and computational models. This is what I do. Now have a look at our VR experiment. In this experiment, actually this is the visual field, this is the VR environment that our participant is exposed to. What our participant has to do? He or she has to decide whether the number of green pixels is dominant or orange ones. These virtual agents have to perform the same task, but note, they're not always correct. Sometimes they make mistake. And by these experiments, we want to determine to what extent the behavior of these agents affect the behavior of our participant. Actually, I mean the decision of the participants. We also simulate this experiment by just computational models, because we want to find out about the mechanisms behind such behavior. Now, our results. Don't worry, I don't want to go into the details. I just want to point out some, oh, sorry, this one is, okay, this is VS and this is group density. It's not as beautiful as I wanted. Okay, I want to point out to four important determinant factors in contagion behavior. One is group size, the number of these avatars, agents. One is group density, how sparse they are located. And then, how fast agents make decisions. And finally, which agents make the first decisions. But the last question is, why do we study behavioral contagion? Many politicians, salespersons, or other professionals take advantage of this phenomenon to influence people, influence people's actions, purchases, votes, and etc. We see that the laughter spreads and makes beautiful moments. But sometimes what spreads is not beautiful or useful. Sometimes, I need some more time. Sometimes what spreads is violence or rule breaking. Oh, this one. What should government and police do about this? They can have strategies. They can be very smart, efficient, and peaceful, rather than being aggressive and suppressive. So, effective interaction with the societal demands needs profound understanding of the society's features and dynamics. And this is what we are doing now. This is not my fault, sorry. It should go to the next slide. Thanks for your attention. This is my contact information. If you have any question, just email me.
Thank you. Thank you, Maryam. Oops. Now the last slammer of tonight is from India. Dr. Ramprasad Misra is from Kolkata. He has a master in chemistry and did his PhD in physical chemistry and biophysics. He likes communicating science, and he does so during his position as a research associate in the group of Peter Hegemann at the Humboldt University, where his focus is trying to understand the structure and function of enzymerhodopsin, a class of proteins that has potential for use in optogenetics, a technique that allows to manipulate cellular functions by light. His title is, the title of his talk is When Light Enlightens Life. Please, with a warm applause, Ramprasad Misra. He starts now, Achim.
Good evening, everybody. Tonight, I will make you see. So, now I want to tell you about, very briefly, one of the techniques that has been successfully utilized to restore vision partially in a blind person. So many of you have probably remember this news couple of years back that scientists use one technique called optogenetics to restore vision of a blind man, and now he can distinguish the pattern, although he cannot see fully. So I think this was a major breakthrough in the field that we are working now. And there are lots of other news outlets which actually mention this news, including one from Berlin that highlighted that importance of the research from our group led by Professor Peter Hegemann, that what we are doing here. So although the word looks quite complicated, the optogenetics, it basically means light that can be used to manipulate the neural activities like our behavior. So although it looks or sounds quite complicated, but actually it's not that much. So let me tell you the story behind it, how this field was developed. Several years ago, scientists found an algae, a green algae, that when excited with white light, for example, the light from flashlight from your phone, that moves away from the direction of the light. Of course, there are some examples where the algae moved towards the light. And scientists now start to think that how an algae, which is not an animal, it doesn't have any eyes, how they can sense the light. And they try to think about it. And then this lead to a protein, they called it channel rhodopsin, and which actually look like this. And one of my colleagues, she was kind enough to borrow this model to me. And this is actually how the rhodopsin looks. It is exactly very similar to that of our eyes. We also call this retinal protein that help us in the dim light vision. So what it has 7 transmembrane alpha helix, and there is a molecule which, like she did 3D printing, that absorbs the light and sends signal to our brain, and that's how we are able to visualize things. So my present research actually deals on this kind of molecules or proteins, And what the scientists did to confirm this behavior, that actually this comes from this particular protein, they prepared a variant of this algae in which this particular protein is inactivated, and they saw that then it does not show any light-dependent behavior. And now, another group of scientists they found different other photoreceptor proteins. So our protein is like this, and also they have many other photoreceptor proteins. They are moved by light. So in the next 45 minutes or so, I will describe what these proteins mean. Okay, I'm just kidding. I have only 8 minutes for this slam. And after this talk, I have to catch a train, which always comes on time. Okay, so I will not spend more time here. And then what scientists did, actually they implemented this particular protein from algae in the brain of the mice, and they excite this particular region, and they found that this can be used to change the behavior in mice repetitively and like how they want. And this led to birth of a new field called optogenetics. Now, you might be wondering that is optogenetics is being only used to cure blindness? No. There are many other fields. For example, the anxiety or high blood pressure and many other diseases can be probably cured by this technique. Although it's not came to the market yet, or it's in a very early, some of them are even very early stage of development, but I can tell you that how the scientific community are trying to address these issues. And before going to this other topic, let us just briefly describe why communication is so important. So we know that communications are really important even we are two people. Even sometimes miscommunication happens between my wife and me, for example, or someone else. So now let us consider a little larger systems. For example, some government consisting of some government offices. And one of my colleagues told this interesting story, and I like it. I want to share it with you. So what he did, when he moved here, he wanted to get a bank account. So he went to the bank, and when he went to the bank, they told, sorry, we cannot open a bank account for you because you need a city registration certificate or Anmeldung. Then he went to the city registration office with passport and all other documents. What he was missing is the signed contract from the university. So they told, sorry, we cannot do because you have all the other documents, but one important document is missing. Then he went to the university. And the university people are kind enough. They told, okay, we already have sent the contract to your home address by post, and which he never received. And after couple of weeks, or even like little later, it was realized that due to mistyping of the postal code, the letter went to somewhere else, which could never be traced. So you see, when we have like these 4, 5 systems, how this works. Now consider a system which has not only 2, 5, 10, or hundreds of systems, but trillions. Then what will happen? So one example is our body. So our body has trillions of cells. And so even if we don't realize it, actually our body is quite complicated than we thought, and they are communicating with each other to keep us healthy and alive. And in our research, in our group, we are working with a protein called enzyme rhodopsin that not only has the rhodopsin part, but a cyclase part here that actually produces the second messenger. And second messenger are known to regulate high blood pressure and many other things. And to give you a little bit more overview about how second messenger works, for example, we have like one person who is not in this audience and want to give an important message to the system, and he just calls me and tell, okay, this is an important message, you should give it to the audience. and I tell you. This is how second messenger works. And scientists are working from all over the world on these topics in which the optogenetics can be utilized to not only cure the blindness, but also to cure high blood pressure, anxiety, and many other things. And if our research is successful, I believe that not only the original research of blindness, I believe that our future is bright. Thank you very much.
Thank you, Ramprasad. You can stay up here. Now, please, let's see all the slammers of tonight. Please, with a warm applause, welcome Maryam and Emma, Tobias and Johannes, Gilberto, Memo and Tanya here on stage. And give a warm applause to Achim for controlling the Zeitschwein. Do you stand in the order of appearance? Please do that. Okay, Tanya is first, then Memo, then Gilberto, Tobias, Johannes, then Emma, Maryam. You're scientists. You're able to do that. Come on. Okay. Who is older than 30 years and watched TV in the late 90s and know the show Herzblatt? You know who Susi is? Okay, I'm trying to do Susi now. Because maybe you lack long-term memory and have forgotten what the earlier talks were about, and you still want to, give feedback and give applause. Because now we want to see who will be the winner of today, right? So, Tanya, maybe you want to see that Tanya is the winner of today. Then Tanya, who likes flies so much that she messes with Flynn's brain while she smells sugar. If you think that she will be the winner of the day, then please, make noise now. Thank you. Or maybe you also think that Memo, who's a bad bunny, and who tells a story of slow and fast bunny systems and perturbing chaos doing whatever. Maybe you think that he should be the winner of today. Then please give noise now. Do noise. Good bunny, thank you. Or Gilberto. Maybe you think that Gilberto, who drives bumper cars with Iris, looks her deep in the eyes and diagnoses MS early, should be the winner of today. Then please, make noise now. Thank you. Or maybe Tobias and Johannes, who fight while studying Catalonia, men and women alike over 2 centuries, and their timeless nationalism. Maybe you think that they should win, then please make noise now. Thank you. Or Emma, who cares for her babies to produce cellulose, packaging, or edibles with multiple benefits, should be the winner of today. Then please, make a noise now. Thank you. Or Maryam, who spreads laughter and other behavior in virtual reality and models to help us against violence and politics. Thank you. She knows how to do it. Yeah. Thank you. Or Ramprasad, sorry, who is loved by the balcony, who makes blind people see. Thank you. We make use of a very, very complicated algorithm that is computing now, but cannot reach a final decision, because I think we have to make a Stichwahl here. Yeah, our very complicated, totally fair, algorithm couldn't really decide if Emma or Maryam are the winner of today. Now, we do it the following way. Now, I'll ask you to come on here to the front. Leave space for me in the middle, because I will come and I will have to put my microphone down in a bit. So we'll do that like that. I will stand there in the middle. And now it's not about time, because I set the time. I need your hands. I'll get here in the end, right? And when I raise one hand, you make as much noise as you can, for as long as I have raised my arm, for only that person. Maybe you decide if you make noise for only the one person or the other, and give all you can, and it's only about intensity. And afterwards, our very complicated algorithm will most surely come up with a decision. Okay? Thank you so much. Nick, bring up the stuff, please. Wait a second. I need the cable. Thank you. So first of all, since everybody is a winner, of course everybody's a winner. Faster, 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 faster. Yeah? Where are the Gutscheine? They are there. Okay. Anyway. Yeah, bring it on, bring it on. Just bring everything on. Okay, before we give the prizes, because everybody is a winner, so everybody will get a voucher. And since they're scientists, it's a voucher for Dussmann for 30 euros. So, yeah, scientists like to read. And then we have this cool goodie bags. These are the vouchers, yeah. We couldn't find flowers, so we made this nice flower-looking posters. And until Nick shares the prizes for everybody, I would like to say thank you. Thank you because you were such a great audience. Thank you. Thank you, Achim, for doing the Zeitschwein. Thanks for Nick for helping with the techniques. Thanks for the guys from the Holzmarkt-Sälchen. Please give a big applause for sound and light. Thanks for Unisysca, thanks for Math Plus, thanks for Scripts, thanks for Matters of Activity, Science of Intelligence, and NeuroCure, for all the people who organized this event. And, well, these are the winners for today. And my name is Jochen Müller, and I would like to see you again. We have so many things during the Berlin Science Week. We see each other, of course, again at the 7th of November in the Villa Neukölln, where we will only concentrate on neuroscience in a show called Berlin Brains. But please, also until then, every day, you have seen the programs here. Read them carefully. We will ask you afterwards. Yeah? There will be a test if you really get everything. There will be a ton of cool events every day. So clear the stage for science. These were the slammers of today. They love you, you love them. Bye, have a good night.